look at some of that math to try and work out how to find the corresponding y coordinate for any x1 in order to keep these gradients consistent or the same. So I have this graph over here to help us explain gradients and straight lines. And I have a line going through the middle, the origin, like our 0, 0 point of our axis. And what I want you to notice about this line is what happens every time I move 1 unit to the right. How much does my y change? So when I go 1 to the right, notice I need to go 1 up to stay on the line. 1 to the right, 1 up. 1 to the right, 1 up. So what's happening is that our change in y from here to here is 1, and our change in x from here to here is 1. So our gradient can be defined, right? Our gradient can be defined as our change in y over x, which is 1 over 1. And this is the key characteristic of straight lines, that their gradient remains the same throughout the line. There's no point at which the gradient is suddenly different. It's always going to be, if you calculate it between 2 points, it's always going to remain the same carrying on. So notice if instead of going 1 across, I went 2 across. If I go 1, 2, I go 2 up. And I go 1, 2, I go 2 up. And now my gradient will be 2 over 2, which is still 1, right? So my gradient, regardless of the size of the step I take, remains consistent. Now we have a cool kind of widget over here I'm wanting to show you that kind of illustrates this, and you can play around with this as well. Let me go ahead and open this up, which as well helps us visualize this. What you'll notice, I'm going to check this box over here that says show calculations. And another way of describing this is something called like rise over run, right? So how much do you rise by versus how much do you run by? And notice, regardless of how much I change this, right? How much I change the 2 points, you can see over here on the right side, the numbers for rise over run are consistently changing, but what they come to at the end is always the same. And I can change what my slope is, or maybe like where I can move it up or down, and the slope doesn't change, right? So I'm moving this line up or down. I can play around with this dial over here, and now the slope does change, right? So now I'm dealing with maybe a gradient of 0.5. So that means for every 1 unit to the right, I'm moving 2 up, right? So we can show this if I bring run all the way to 1. Oh, for every 1 unit to the right, I'm moving 1 up. Sorry, yes, of course. If it was 2, it would be 1 unit to the right would be 1 up. But you can see, regardless of how big that size is, that gradient remains the same. Okay, now we have that piece of theory behind us. Our task now is that, okay, if we have these 2 points, right? Say we have these 2 points that are defined by what we do. So we have point 1, let's do this in another color, over here, which is at -2, 0, always x coordinate first. And this is the other point over here, which is at 0, 1. Now we know that the gradient, if our goal is to find, if we're at this x coordinate, some x coordinate over here, and we know, hey, what is this y coordinate over here? We know that the gradient joining these 2 points, so if I zoom in a little bit more here, I'm going to choose another color. Let's go like this. This gradient over here, right? So this change in y, I'm going to put a triangle. So that triangle is often referred to as delta, right? Which is delta is like another fancy word for change. We're fancy over here, so we're going to use fancy symbols. So that's delta y, or change in y. And then this over here is change in x, right? So how much we change our x, how much do we change our y? So we can see we're going 1 up, right? Our change in y, our delta y, is equal to 1, and then this is 0, so 1 minus 0. Our change in x, we're going from 0 to -2. So that means our change in x is 0 minus -2, the distance from 0 to 2. So it's just 2. 0, you can say 0 minus -2, which is equal to 2, and that's equal to 1. So therefore our gradient, we can say g, usually we end up using the symbol m for gradient, is equal to 1 over 2. So now we know that our gradient is 1 over 2. Now, this gradient, if I now draw a triangle from that point to there, we know that this change in y over this change in x has to be equal to 1 over 2. So if I know, for example, let's say whatever this x coordinate is, let's give it a value of 10. So our x, this x over here is 10. So our change in x from this point, right? So this is at 0, 1 over here. So we're going from 10 to 0. So that means our change in x, delta x, for this one, is equal to 10. Our change in y is the following. It's going from there to there. So we're going from 1. Now we don't know. Now there's the key. We don't know what this y coordinate is. That's what we're trying to work out. But we know it has to be a value such that when I go, so I'm going to say delta y is equal to whatever this y is. Let's give it a value y minus 1, right? Because that's there. We know, so we can say y minus 1 over 10. That change in y over change in x must be equal to 1 over 2. And now we can just solve for y. In order to solve for y, I can say y is equal to 1 over 2 times, okay, let's go through this one step at a time. So we'll go y minus 1. I can multiply both sides by 10. So I get 1 over 2 times by 10. So I say y minus 1 is equal to 5. And then I can say, take the 1 over, so I get y is equal to, where minus 1 over the equal sign turns to plus, y is equal to 6. So then this y coordinate must be 6 if x is 10. And yeah, that's pretty much it. But let's make sure, right? Let's test it. If I say 6 over here, 6 minus 1, I get 5. 5 over 10, 1 over 2. So we know that's right. Let's see if we can't translate all of this math now into some code.